Good afternoon or morning, depending on where you are. Welcome to the NSGIC 3D Hydrography Program for the Nation monthly info forum. Today, we're glad to have Steve Achel with us from USGS. He's going to give us a program update, where we are, where we're going, and do a bit of a data demo. But before we get there, just a reminder, this is a NSGIC USGS cooperative agreement project working collectively between the two agencies to engage state and local governments and private sector partners in the development of the 3DHP data resource. I'm gonna move a little fast today because I always give you a short project update, and today it got a little, because we're so late in the year and we've been so busy, I am going to go rather quickly through this to bring you up to speed. I think I'm ahead of a slide. You'll see on the right are our primary project activities, and then we'll be talking about specific activities on the left. One of our project activities is to host this monthly forum. If you're new to the forum and you want to see past forums, you can access that at the NSGIC knowledge base at this link. I'll put a series of links in the chat in just a minute. Do note that is a login required to get to that information, and we'll talk about how you can get a login in a minute. We also manage the 3DHP for the Nation interest group. It's a general interest group to talk about 3DHP, project updates, and your activities. NSGIC members can join at mynsgic.com. And if you're not a NSGIC member, that's not a problem. Please still join. This is the way we get most information out to the community. And you can go to the link shown here. And again, I will pop some links as soon as I'm done talking I'll pop these links into the chat in just a second. The second task we have is to establish a hydrography communities and online working, or as part of hydrography communities and online working space, we have also have the hydrography stewards community. And that's a community for those that manage statewide hydrography. That can be an NWI designated steward or just a state designated steward. It's open to NSGIC members and non-members. So if you have a hydrography steward in your state that's not necessarily part of your NSGIC team, please have them fill out the form at this link and join us, because there's a lot of good dialogue that's happening there. And they just held a meeting October 5th, and the notes from that meeting are available in the library section of that community. 3DHP experience inventory. The idea is that we capture information insights about 3D hydrography activities. There's two online forms for documenting your activities. So if you're active in 3DHP, EDH, we'd love to hear what you're doing. And that information is all compiled into the 3DHP FTN activities dashboard. We'll talk about that a little bit more in a second. And on that activities, Phil recently did a big effort where he mapped all of the activities to the HRBS case study types. And we're hoping that's going to facilitate people in developing their DCA proposals, which I don't have on here are due Friday. DCA proposals due Friday, 3DEP and 3DHP. With regards to supporting states in 3DHP planning, one of our activities is to identify issues and needs, and that's where the critical factors work came in early in the project. And it was a survey of concerns and factors affecting state implementation of 3DHP. And we will be revisiting those because they're evolving action items as the program develops. We have new thoughts and options for addressing those. So we'll be having an interest group meeting next month in lieu of the info forum, and we will be revisiting the critical factors. In addition, we're to develop 3DHP planning guidance documents. There was one document out there right now. It's a one-pager, and we're USGS. One of the things we've identified for this next project year, if funded, is to update the existing 3DEP planning guide to serve more as a 3D national topography model data planning guide. And obviously, we'll be coordinating with the 3DEP project on that. All of that information is in the is at the info hub. Again, with supporting 3D-HP implementation, most of you are aware we held a workshop at the NSGIC annual meeting. It was in person only. Great turnout, great discussion. We're setting up a page at the 3D-HP info hub to house those materials and information. But in the meanwhile, you can access this handout that was used as part of the workshop. And then under provide 3D-HP program and data development feedback, we have regular coordination with the federal 3D-HP community. We have a monthly project coordination meeting with NSGIC that's focused on the 3D-HP for the Nation project. We do monthly participation in the federal 3D-HP working group. Dennis Peterson, I believe, is on the call. Dennis is the NSGIC liaison to that federal working group. And we organize NSGIC reviews and responses to announcement activities such as 3D National Topography Model calls for action. I'm going to go grab the links for the chat. I see there's some sound issues.
Yeah, we're working on it.
I hope that has been resolved. Here comes the link. I will open it up to our project engineer, Phil Worrell. If Phil has anything he'd like to add on these activities, he didn't know I was going to do this. So, Phil.
Thanks, Linda. One of the things I'm also trying to do is bring in the mission critical activities for the that are part of the business use cases. There's many more mission critical activities, and some of those get into more finer granular detail than the business use cases for 3D-HP. I'm working on trying to integrate those. Steve H. has shared some of his original spreadsheets when the needs assessment was done, and I'm hoping to bring those in as well. So I folks a little bit more finer examples of how they can look for applications and uses and justification and funding for their 3D-HP efforts, but that'll be happening here over the next weeks and months.
Any questions or comments about where we are project-wise? I will mention that this project year ends December 31st, and NSGIC, my understanding is that NSGIC and USGS are in coordination to hopefully renew the project for its last project year, which will be 2024. Lindsay, did you want to make any comments on that, or?
No, just that we are in process.
Sounds great. Any other questions about project activities before I turn it over to our speaker? All right, please enter your questions into the chat once the presentation begins, and they can be about anything. I really ask you to put them in the chat because we capture them there, and we develop the Q&A document that is posted. And if you didn't know, after every info forum, we do develop a Q&A document and post it to the NSGIC knowledge base. With that said, I would like to introduce our speaker today. Most of you know Dr. Achel. He's the Hydrography Manager and Planning Lead for the USGS National Geospatial Program. And Steve is going to be talking today about the 3D Hydrography Program, its status, plans, and a data demo. I will stop sharing, Steve, and you can share.
All right, thank you, Linda. There we go.
There you are.
All right.
Looks good.
Great, fabulous. All right. Well, thank you. As Linda mentioned, my name is Steve Achel. I'm a geographer with the National Geospatial Program and currently serving as the Management Planning Lead for the 3D Hydrography Program. Linda, it seems like I talk about this a lot, but when Linda mentioned that I hadn't actually spoken to this group in about a year, it seemed appropriate to come on to this particular group and again do a little bit of a status update, talk about where we thought we were going, where we ended up going, and where we think we're going in the coming year. And so with that, we'll get underway. For those of you that tune into my talks regularly, you will see repeat slides. On the other hand, I think I have seen a number of names go by on the attendance list that I don't recognize. So there may be some new people in the crowd as well. There is new material in here, and again, if some of you that have listened to me talk on multiple occasions know sometimes I just say different things. So we'll see what happens. There we go. So I like to start here actually, because this is where topographic mapping really began for the USGS. And these topographic maps have been the basis for, I mean, really any number, I mean, actually fundamentally the basis for the American geospatial industry for many years, right? This is where the census road file started. This is where RF1 started, for those that remember things like that. This is the NHD. This is the NED, the National Elevation Data Set back in the day. And these have been used in all sorts of ways.
We're not seeing your slides.
Yeah, Steve.
Oh, well, then that's not as good.
We're seeing you, but we're not seeing the slides.
Well, then that's definitely not as good. Let's see what we can do about that.
We were seeing them until you started the presentation.
Rambling on, huh?
Then they disappear. There they go. There they
Okay,
are.
there's John Wesley Powell, and we'll pick back up on this. Okay. So again, topographic maps are really the basis of the American geospatial industry. They're used for all sorts of things, from from land management, planning and zoning, certainly lots of natural resource management, science, and and backpacking and hiking and hunting and all sorts of things. Over the years, of course, those things have changed, right? You have sort of a vintage topo map up in the upper left there, and one of our newer U.S. topos, and then an actual, an online rendering that we update a lot more frequently. I think we can all agree that just back in the day, the way you shared geospatial data was through a map, and now we can do it a little bit better. For those of you that are cartophiles out there, I do want to call out our Topo Builder website. This is just very cool for anybody that's ever taped together 4 topo maps to make a map of your field site or something. If you have a little time, it's late in the day or something, go poke around a little bit. You can make a nice custom topo map. That said, again, maps are kind of one-dimensional, right? Two-dimensional, I suppose. Where we really want to go is towards a 3-dimensional topographic map. And that is the 3D National Topography Model. This vision, this destination is on the right. This is integrated 3D data built off 3DEP, built off 3D renderings of structures, understanding of geology, aquifers, wells, all that sort of information built into a virtual 3D cube. We're going to be a little while getting there, but it all starts with where we are over on the left side, which is with the 3D elevation program, 3DEP. And I could have updated this slide. We're actually, as of the end of last fiscal year, a couple weeks ago, at 94% completion for the United States. So we're rapidly closing up on the end of the initial baseline collection. I expect to have that done in FY26. We also built the NHD Plus high resolution, which many are probably familiar with. This was an effort to take the NHD, which was really water bodies and streamlines and a variety of other features, and take those, add catchments to those, really try to integrate those with the elevation data. And demonstrated some very positive things in terms of the addition of catchments and the addition of networking attributes to the data set. It also demonstrates some of the limitations of working with the NHD vintage data in the context of the LiDAR elevation data. And so where we're going is that middle box, the next generation programs. First is the 3D hydrography program, which we're going to talk a lot about today. I'm going to talk almost exclusively about going forward here. And the next generation 3D elevation program, which we're just describing, getting started at this point. But that's going to introduce new quality levels and more rapid refresh cycles for the data in the future. And so the 3D hydrography program, this is why we're here. And this is sort of the line in the sand. This is what we're doing. 3DHP is the first systematic remapping of the nation's hydrography since the original USGS 24K topographic mapping program was active between 1947 and 1992. You think about sort of where we are, and we'll talk a little bit more about this through the session. The last time that the nation was mapped in a consistent way, the last time and the first time the nation was mapped in a consistent way, was for those topographic mapping activities in the middle of the last century. And we have pushed that data far beyond anything anybody that collected it thought it could probably do. But we pushed it to the edge. And so for 3DHP, we're going to build new data. We're going to put it in a new database, and we're going to generate new products from it. So, so why modernize? Are we disrupting just to be disruptive, or is there, what's the rationale behind this? First thing is that there are lots of applications of hydrography data already. The NHD, WBD, NHD Plus support about $538 million in annual benefits back in 2015 when we did the hydrography requirements and benefits study. But we also discovered that a modernized 3D enabled program would provide about a little bit better than double that, about 1.14 billion in annual benefits, and actually probably more than that, in that a lot of those sort of future uses were reported but unquantified by the agencies that responded. And Phil is wading through that data right now, so you may get questions you ask him. But maybe most fundamentally, the difference is it's not a plus or minus 40-foot world anymore. This graphic on the right is courtesy of Josh Greenberg in Washington, and shows in green the NHD flow lines, and in blue the flow lines derived using the elevation-derived hydrography standards that we published a couple of years ago. And in addition to the feature density, there are actually some pretty fundamental differences in that drainage network. And that's again, it's an indication of data that were collected quite possibly by those guys in the lower left corner, with big beards and bigger hats that were out with plane tables and stadia rods and theodolites and so forth, and trying to compare that information to the things, the kind of precision that we generate from LiDAR. And maybe equally importantly, 20, 30 years ago, when I actually got to do things out in the field, we would take a topographic map and go tromping off in the woods and find a creek and sample that creek and mark it down. And that's all fine. And we'd probably, if we walked across this area and found a creek, we'd probably say it was that green line, and that was good enough. But nowadays, when everybody has sub-meter, meter-ish precision GPS in their pocket, those differences matter too. And so we need to be able to reflect what's going on the actual landscape much more closely. So of course, we compared some scenarios of how we could do this. And of course, the first scenario is always to do nothing, and sometimes that is the right answer. But there were some significant issues in that approach, most notably the inconsistency in the data. If you look, we'll look at this a little bit as we go forward, but there's some major things that can't be done, couldn't be done with the NHD the way it was. Similarly, we looked at sort of the high-end solution, but that would have required, among other things, half-meter DEMs nationwide, which would have taken a lot of time and a lot more money, because that would have actually required a recollect of the elevation data. So we looked at what we could sort of feasibly do, and that came down to the middle solution here. And we've obviously simplified this dramatically. There were probably at least dozens, if not hundreds, of different variants of this, but really came down to basing it on the 3-depth elevation data and restructuring things to be able to meet most of the needs in the hydrography requirements and benefits study. And so to sort of understand this again, I apologize a little bit for flipping back and forth here between the NHD and where we were and sort of where we're going. But you do sort of need to understand where we've been for the last 30 years in the hydrography community to understand sort of what we're leaving and where we're going. The NHD and and the NHD plus high res and the WBD were good products that were generated over decades most typically from the cartographic products. Most of the line work in the NHD was still based on the lines that were drawn on those 24,000 scale maps a few decades ago. But they were comprehensive across the country. And certainly in 2007, when that high-res data was completed, that was when digitizing that high-res data was completed. That was a consistent, comprehensive data set, and has been sort of the nationwide data set ever since. Similarly, the WBD was generated from topographic maps most often, and has been a staple really of data collection and reporting since it was put together. And this work was done in collaboration with a lot of entities around the country. Stewardship agreements at various points with 41 states and Washington, D.C. A lot of agreements with other federal agencies. But those of you that are math inclined would realize that 41 states isn't 50 states. And so there were 9 states that didn't really participate in the stewardship program at all. Similarly, those other 41 states sort of participated in different ways and to different degrees. Sometimes it was very project-based. Sometimes it was statewide to a particular standard. Sometimes it was statewide to no particular standard. We had a lot of different things going on. And as a result, the data in the data set sort of grew apart from each other. It became less consistent through time, as some of that line work was still based on the old blue lines. Some of it was based on some other data set, some other standard. And it was difficult to run applications that spanned any significant area. And then finally, again, it just didn't align well with the 3D elevation program data, or GPS for that matter. So where we're going at sort of a programmatic level, we really want to make sure that the new generation of hydrography data aligns with the elevation data. That's a fairly straightforward requirement. Somewhat easier said than done, but a fairly straightforward requirement. We also have the advantage of having 3-depth go first. So we've been able to adopt a lot of the governance practices. We've been able to add on to the 3-depth data collaboration announcement to do collaborative work with states. We have a lot of contracting experience now through the geospatial products and services contracts. And we have, the experience of data validation to dedicated specifications. That's something else we'll talk about here in a moment. But the other thing this really gives an opportunity to do is to build a data set based on hydrologic requirements, hydrologic applications, rather than kind of retreading a cartographic data set to do hydrologic work. Eventually, we also have a vision for this to be link together things like groundwater, the NWI, stormwater systems, and really provide a better accounting of water throughout the system. So I put this up, and obviously it's illegible. It's just supposed to leave an impression. But this is the world we're coming from again. Up on the upper left is the NHD data model. On the upper right is the watershed boundary data set data model. And in the lower center is the NHD plus high-res data model. And collectively, there's about 250 different feature types. A lot of layered relational tables, lot of issues that, a lot of repetition across these data sets, actually. Most of the NHD is replicated in the NHD plus high res. Actually, most of the WBD is replicated in the NHD plus high res. Some crossover between the NHD and the WBD. There's a lot of things to keep synchronized across these different data sets. And we had a lot of big tool stack to do that. 250 million, or I'm sorry, 250,000 lines of code to try to keep this stuff together. Primarily in about 13 tools, which happened to all be written to the ARC desktop technology, which, at least for Department of Interior, expires 1st of February of this coming year. So we were looking at a fairly big technology lift to replace that code, and some reasons not to, frankly. So in the technical side, we had a couple pretty straightforward goals. Again, really radically simplify these data sets, learn from the NHD plus high res experience and make those catchments really integral to the system, not something we do later. Use the catchments themselves to build the hydrologic units that will replace the WBD, and then really simplify that workflow all the way through. Make that a much more rapid update cycle, make that a lot easier to manage and a lot easier to use. So I mentioned, sort of a cartographic data set retreaded for hydrologic purposes. One of the challenges was that back in the 90s, when the 100K NHD was being sorted out, really anything that sort of was water adjacent on the map ended up in the NHD. And so these, so we have stream rivers and we have canals and we have water bodies and we have that sort of thing. But we also have 22 different flavors of pipelines and 24 different flavors of reservoirs, including within the reservoir group, things like swimming pools and treatment ponds and filtration ponds and settling ponds. And the extent to which you can tell the difference between those in LiDAR is relatively modest. These all sort of look like water bodies. And similarly, there's some questions to whether, sort of the hydrologic value of a swimming pool. Then we had things that just weren't, levees and rapids and rocks that had appeared on a map somewhere, but maybe weren't consistently mapped and definitely weren't consistently updated through time. But carrying all these features around made the tools very complex, made the data management exercise very complex, and eventually, really carried a lot of risk for classification error. These things, by pushing the classifications to this level of specificity, we were almost guaranteeing a lot of error in those classifications. And so this is problematic in a variety of ways. So where we went was really from the ground up, starting with a new data model based on the OGC water ML standard for high features. And this is something that we're working closely with Natural Resources Canada to try to help them implement it. NOAA and the National Water Model folks are basing the next generation of the National Water Model on this system. And within USGS, there's a adoption of this system for future applications like water census. So what this does is it allows us to work with a common set of features and vocabulary, really based on, again, the hydrology and how the water flows, rather than trying to differentiate between a settling pond and a filtration pond. It also simplifies the network in many ways so that we're not carrying as much attribute information on an individual feature, but we're allowing that information to be addressed to the feature. And so this is what our new data model looks like. Again, I understand this is illegible, just hang on a slide or two. But what this does is it allows us to represent about 95% of the features from the NHD, WBD, and NHD Plus, with about 10% of the feature types. And we do a lot of that by reducing the repetition. So we don't have flow lines in two different places. We don't have watershed boundaries in two different places, but also by focusing on that hydrologic content. We don't have swimming pools in this data set. So if you want to go in and see what we do have, see the descriptions, pay attention to the next couple slides. Over on our website, our brand new 3DHP website, usgs.gov/3DHP, we have a place on the left for, oops, should throw a circle in there, We have a link over here for documentation and specifications. If you hit that, you go to our standards and specifications website, go to hydrography, and you'll see product specifications for 3D HP products, and then a separate category for elevation-derived hydrography acquisition specifications. This is kind of an important distinction that is different from the way things were done in NHD. We have this EDH specification for really kind of the raw materials that go into the system. This is the geometry primarily with some fairly minimal attribution. The 3DHP specifications are, the actual finished products. And so if you want to learn more about those, you go in. Here we have a products page. We have a link to the specification. We have crosswalk tables. So if you want to know where that NHD feature ended up in 3DHP, you can look that up. You can also see the relationship between elevation-derived hydrography features and 3DHP outputs. A lot of references on how we came about this. And then if you hit the 3DHP all 2023 specification, this is the service that we have up, the comprehensive service showing all the data at the moment. You go in there, service description, while there are good metadata kind of things, and then data dictionary links. So you can go in and see the flow lines and what feature types we have. You can read the difference between a canal and a river or drainage way, or figure out what an elevation breaching connector is. There's an unfortunate limitation in our Drupal system at the moment in terms of showing wide tables. So you have to do this scroll thing, but you can working on that, and in the meantime, just sort of work through it. So that's the product that's up at the moment. I show this because, as I mentioned, we have a acquisition specification and a product specification. And we're really trying to separate these things into sort of bins rather than this sort of cloud web of a workflow that we had before. That was really based. A lot of this was based on being able to edit, anything, anywhere, anytime, and have that re-ingest into the system. So we moved away from that towards a more structured system that first starts with elevation-derived hydrography, which will validate and make sure that meets the specifications, make sure it's clean data. Then ingest that into the core 3DHP database. It's an internal, enterprise geodatabase. But this is where a lot of the magic happens. This is where the catchments are generated. This is where feature IDs are created. This is where network attributes are created. And then publish that information, publish subsets of that information typically out as user views, as services, as static products once in a while, to be able to provide users, sort of use case specific products. So to populate the data set, and this is where we do break a little bit from what we had planned to do a year ago. About a year ago, I came on this call and talked about populating with elevation-derived hydrography data, and then just a skeleton between those data sets. With some significant user feedback, that we're not doing that. We shifted over to ingest the entire 24K NHD, around 95% of the 24K NHD, into the 3DHP schema data model. So it has the new ID scheme. It has new attribution, new all the different sort of bells and whistles on 3DHP, although it doesn't have all of them. And it actually will never have all of them because it doesn't necessarily match. It doesn't really match with the elevation data. But it's all there in one place, so that if you want to get the best, at least 2D geometry available, you can go to 3DHP and get it. Over time, as we have more and more elevation-derived hydrography projects, we are going to populate that data set with data from 3D or data from the EDH projects and replace that NHD data. And this is another fairly important point. About in 2020, we published specifications for that data. Those are available on the website, but those specifications are the first comprehensive hydrography specifications since the topographic maps. We had some draft specifications published or draft specifications dated, I guess, 1999 that governed what was in the NHD. But this is kind of a big deal and a big level of specificity that we're able to have formal standards that are available to everyone. And so, you know, as a data producer, what you have to be able to do, you know, as a data consumer, what should be there and what shouldn't be there. And this is a big step forward from where we were with NHD. Similarly, we are doing data validation prior to ingest. I mentioned that earlier. We want to be sure what we're putting into the data set meets the specifications. And so we have a fairly complex, fairly rigorous set of tests that we run. Each of these little bullets represents a specific test for a specific component of the specification. Over on the left is a pre-check we run against a sample data set that contractors or cooperators provide. Then on a full delivery, we do a somewhat more elaborate set of tests, same set of pre-checks, and then some more specific tests, assuming that first set pass. Then it's actually just found out today, we've finally gotten all of this coded into a single ArcGIS Pro toolbox. And this should significantly accelerate the pace of these reviews. So this is mostly by way of saying that we are actually, you know, checking this stuff pretty rigorously, and you should have some confidence in the data that you're seeing. Data improvement. This ended up being a little bit more complex than maybe we initially thought at the beginning of last year. We're still looking at, as long as we're doing this validation, we want to be pretty careful about the features that we move in the data set because we validated them against the elevation model. But there are going to be things that change. There are going to be mistakes. We're going to talk about a couple 100 million features. Some of them are going to be wrong. We want to be able to collect corrections from eventually the public through a web interface similar to what existed for the markup tool in NHD. But we want to vet those corrections, those suggestions through state stewards ideally, and so that they can check what, make sure those things are valid changes. We don't want somebody putting in, you know, nefarious changes to get out of a permit or something, you know. But at the same time, as we started looking at implementing this, it became apparent that that there were a lot more possible scenarios here and potentially some issues with some of those scenarios. And so right now in 24, rather than developing a tool that we'll have to revise, you know, many times, we're doing a little bit more research on these workflows, looking at putting some tools out in 2025. For the time being, if you have data issues, report those through your liaisons. Some of them we will be able to address, some of them we won't. And we'll just report those through liaisons. But at this point, we're trying to get an understanding of what kinds of issues we're going to see. Data distribution. Again, one of the ideas here is to get away from having sort of lots of different iterations of stage products. NHD and WBD would often be updated, you know, monthly. And that was challenging in a lot of ways, particularly for people in the research community who wanted to have a referenceable product. So we're going to have services as sort of the primary way of getting the data, and that'll be updated more or less continuously. And that's one of the benefits of that is it allows everybody to work off the same data frame. As we're doing addressing, we're trying to support things like the Internet of Water. Everybody's using the same base map. But we are going to have annual static releases of the data so that you can tell what the data set looked like at the end of 2023 or at the end of 2024. And if you're somebody that needs to reference that work, that'll have a URL and a DOI number for reference, so that someone else can pick up that data and do the same thing that you did to it. And so now we're going to look at what the data actually looks like. This is an example from Alaska. It's PUC 1905-0401. Sorry, 1905-0401 for those who want to play along at home. And this is just a little bit of an example of what we're showing or what's here. Obviously, dark blue lines, streamlines. These lighter blue lines, or cyan, are catchments, or they're derived from the IFSAR data. And there are a couple little things we're tweaking here, like this little thing is probably not quite right. But overall, again, we have catchments, we have various kinds of hydro locations marked out on the map, and this is what eventually the whole country will look like. Unfortunately, at the moment, most of our EDH data is in Alaska, and so we'll work on publishing that this fiscal year. Work on any other data sets that we've accepted, work on ingesting those this fiscal year. But again, we're something like 65-63% in process in Alaska, and we're a couple percent in process in CONUS. So it's going to be a little bit in CONUS. Meanwhile, people probably want to look at CONUS. So as an example of where I'm sitting, and my office happens to be over here along the Yellow Breeches Creek. But I clicked on the kind of Deguinnit up here because it has a funny name, and shows some of what we have in the data set now. So this line work is from NHD, but it has this main stems address, which is new information. All the features carry a features that are named carry a GNIS ID, but we're not repeating the label. We're pulling that label from GNIS directly, so that some of the mismatches we've seen between NHD names and GNIS names can be avoided. As a couple different bits of information. It's a feature type 5. It's a water body connector. Feature is on the land surface, which is useful for things like driving catchments. There's some more attributes here that we will work on populating in terms of particularly the value-added attributes from NHD. But if you follow that GeoConnects link, it takes you over to this other GeoConnects page, right? And it identifies things like so it's actually a long page of attributes. Identifies things like the downstream ID of the main stem, right? So that was the kind of Deguinnit Creek, flows in just north of Harrisburg, and it connects to the Susquehanna River, right? And so that linkage actually helps provide, that's the starting point for being able to search for data through the network, through the tabular system of the network, rather than through the geometry of the network. I'll also note here things like the outlet RFID, RF1 ID, right? So people remember RF1 from the 90s and sometimes later. That's the same feature, the kind of Deguinnit Creek in RF1, or the same feature in NHD Plus version 1 from 2007 or 8. And so this is kind of the Rosetta Stone that allows us to take addressed features from these legacy data sets and bring them all up to the new data set. And this is sort of the basis of the Internet of Water, right? We want to be able to address all the water data that people are out there collecting to one common geospatial framework and make that searchable through this GeoConnect system, so that eventually it's as easy to find stream gauge or water quality information as it is to find a Starbucks. And all of that begins with data. That's where this whole party needs to start. And we're very excited to have our data collaboration announcement up, as Linda mentioned. The initial submissions close October 20th, but we do accept proposals after that. And that is really a collaboration between sort of the federal groups, which are represented on our 3D HP working group. Linda mentioned NSGIC, Dennis Peterson is a representative to that. But that's when we work with federal agencies, we have we have one set of rules that apply to working with federal agencies, in that it's very easy to transfer funds across federal agencies. And so with an interagency agreement, we can work with NRCS or Forest Service or FEMA or sort of anybody in the federal space. And we work to collect requirements, mapping priorities from those agencies. We work on collecting money from those agencies. And then through the data collaboration announcement, accept proposals from states or other non-federal entities, and rate those against a set of criteria, just like it was any other proposal, to come up with selections. And one of those criteria is whether those overlap with federal priority areas. But working through that process allows us to have a fair and equitable way to assess, what is, at least in 3DEP, typically more demand for collaborations than we have money to fund. Moving on. So this is where we are today. And actually, as I mentioned, we're at about 63% of Alaska is somewhere in process. So we've been mapping in Alaska since 2019 with a couple pilot projects, and that's been supported by our Alaska mapping funds. It's been great. It's been a great place to learn things. It's been a great place to kind of train contractors, kind of work with contractors on what our expectations are for these projects. And as noted there, at this point, we're almost 2/3 of the way through acquiring the state. In CONUS, we're moving a little more slowly. We have 13,000 square miles in process through the end of 22. So those were primarily pilot projects, a couple projects funded by NRCS in 22. And then last year we got $500,000 in new money for acquisition, which was great, but it's going to take a little bit more than that. And leveraging that with primarily Forest Service and NRCS funding, we were able to acquire 45,000 square miles, shown in this sort of cyan color around the country. There are also several states embarking on their own projects: California, Washington, Texas, Missouri, Michigan, Georgia, and maybe a couple others. And we're trying to talk to these folks, make sure they understand the specifications, understand the processes in place for reviewing the data. And then we're, again, working towards replacing that NHD data with elevation-derived hydrography data that's been validated against the 3DEP LiDAR. So where are we today? Today, we have launched the formal data acquisition program, which is a big milestone and represents a surprisingly large amount of effort just to get that out the door. But that initial deadline for projects is October 20th, so 3 days. If you're not going to make it then, that's fine. We do accept projects later on, but it's sort of like college admissions, right? We start review October 20th. We are, as I mentioned, accelerating the review and validation of incoming data sets. So that process really stood up from scratch in 2020, and has been actually kind of a fascinating exercise to take what people see as, that looks right, that looks wrong, and try to quantify that in a way that a computer would understand, in a way that we can apply to tens of thousands or hundreds of thousands of square miles on a fairly brisk pace. So that we just released released internally, that is, a new set of tools to do that, and expect that process will move more quickly. We do have one Huck 8 of elevation-derived hydrography data published in Alaska, 1905, 04, 01. And we have that preliminary data set populated across the country. We're working on getting the final national NHD out the door. The national version, I should be specific, the national data set is ready. The regional data sets, the staged products need to be regenerated, and those will be regenerated this month. We're working on the next to final WBD. We closed editing of WBD externally in June, and then we'll have a staged product, again, probably in that October timeframe. And then the WBD team internally will work on a number of problems that they've identified over the years that have kind of been backlogged, and publish another static version of the WBD towards the end of FY24. And then sort of our last piece of the NHD plus HR puzzle will be another national release 2, in spring of 24. And the big difference there will be that it'll include alternate flow tables. So so in addition, sort of the geometrically derived flow tables that are in release 1, there will be an alternate set that were developed by our water mission area, connecting a lot of the disconnected network areas and making judgments, I guess, about which disconnected networks should be connected. Where are we going? We want to actually get some of these partnership-based data acquisitions out. We have the theory, we have the example from 3DEP, but we haven't done one in hydrography yet. So we want to make sure that happens. We'd actually like to do a lot more than one. And so that's Sue Budo's main activity for the year. We want to continue to improve those acquisition validation processes. Again, we need to ramp that up to the point where we can ingest that stuff quickly, ingest the backlog of the validated EDH deliveries that we have, with data we have validated over the last few years. We want to release a cartographic view of the data and a linear referencing view. And that linear referencing view would support linear referencing tools for points. And then we're going to start with the points and then move to line events. And then finally, continue working on research for the corrections process. What can we change without breaking something in the network? What can't we change without breaking something in the network? And how do we not break it when we change it? So there's a research process going on there. And then I'll just show this. This was put together by Eliza Gross, and this is an area sort of between Harrisburg and State College. But it shows the NHD in kind of the pink color and the EDH data that was collected in the blue color. Gives an example of sort of the difference in density and, to some degree, the difference in spatial precision. There are significant. This is a fairly well dissected landscape. So this is, they're pretty strong stream valleys here. But but there's still some significant differences in some places. So, and then sort of the key takeaway slide, right? So again, the idea here is the first systematic remapping the nation's hydrography. We want it consistent, comprehensive, coast to coast. I don't know if I emphasize this sufficiently, but NHD, NHD plus high-res and WB are not going away. They are frozen, but they'll be available. Those services will be available for a long time. It's going to take us about 10 years probably to refresh the country, contingent on funding. So that's those will be around for at least that long. We have built 3DHP based on the final NHD line work, and new data acquisitions will go directly into 3DHP without stopping through NHD. And so with that, I will pause and field a few questions.
All right. Took me a while to get off of mute. Steve, you're fortunate today in that you've had some help with the questions in the chat. I'm going to let you confirm or deny. I think we can start. Josh was asking about the GeoConnections website and whether that is new for 3DHP or pre-existing. I mentioned the Internet of Water. You may want to elaborate on that.
Sure. So GeoConnects has existed for a couple years. shepherded primarily by the Internet of Water folks, but it does include, as I noted, it includes references to most of the major sort of legacy hydrography data sets. So RF1, NHD, NHD plus version 1, NHD plus version 2, so that we can go through and cross-reference across those data sets based on that main stem ID and migrate events from all those old data sets over to 3D HP.
Okay.
So we got here.
Jamie was asking about the main stem ID, whether it is a value or whether you can use it to link to other data. Greg gave a response about the number at the end of the URL being unique. I'll let you read his response and again, confirm or deny.
Well, I don't necessarily want to disagree with Greg because he's actually in the data model group. But maybe it's useful to take a minute and think about. I mean, I'm not down in the bits and bytes of this so much anymore, but think about sort of what we're representing with the main stem ID. And really, it's the main stem ID is attached to line work, but it's really about connecting the headwaters to the outlet. And you can think about the Mississippi River from I don't know, whatever it is, Lake Wobegon or wherever it starts, down to the Gulf of Mexico is maybe that's main stem 1, right? And then the Ohio River is main stem 2 from Western New York down to Cairo, Illinois. The main stem 3 might be the Missouri River. And so we're gradually building out this network. It isn't exactly the same as hydro sequence or something like that, but it's similar and provides a really, again, a way of identifying the pathways from the headwaters to the outlets, maybe as much as the specific feature along the way. I don't know if that, hopefully that was helpful and not just confusing.
No, I think that, thank you. I backing up and looking at it conceptually at least helps me. Phil asked if the initial 3D-HP all service is 2D or 3D, and did it come from the legacy NHD? Again, Greg's offered some information here that it's EDH sourced, and I'll let you expand.
Yes, so most of the network is based on legacy NHD, and so is 2D. The Z values are not present, not populated. 1905, 04, 01 in Alaska is EDH, so it's 3D vectors. Yeah, and we will be updating those, replacing that 2D data with 3D data as we collect it. I see Sue's geoconflation question, and David Anderson, who's leading our geoconflation effort, fielded that. Thanks, David. I don't think I can add anything to that. Oops, move around.
I can't keep up with all the answers and the.
Yeah, that's great.
You're getting good help today.
Phil's going to add the data service to the hub site. That's good.
How about Jamie's question here about the main stem is, oh, we already talked about that. Did you want to? Greg responded, it's unique for rains. All right.
I don't think I think
you've got that one.
Bits and bytes.
Any other questions? Got Steve on the line. Steve, he knows a lot.
And more importantly, people that also know things that are willing to
are on the line.
Right.
Hey,
Any
Steve, it's Dennis Peterson from Tennessee. How are you?
Hey, Dennis, I'm all right.
Good. Yeah, I think you had a slide where you're talking about the FY24 funding. Did I see 1.5 million?
Yes.
Is that pending congressional approval and budget, or what's the status of that?
So that 1.5 million is in the president's budget. And so at the moment, we are operating on a continuing, I think day 16 of a 45-day continuing resolution. at FY23 levels. So that 1.5 is not available yet. If Congress sorts
Ever
through
gets their
other
act together?
well, yeah, if Congress sorts through what else, the other things that are going on, and sees fit to appropriate us, then that's what the president requested to have appropriated.
So you're looking, so it's you got 1.5 to divide amongst any of the DCA proposals that you get in for FY24.
1.5 of USGS funding. As I mentioned, we also work with a variety of other federal, a number of other federal agencies that often will partner on projects as well.
Okay. Yeah. Thank you.
So we're sort of the clearinghouse in some ways for that, for making matchmaking here.
Additional questions for Steve?
Hey, I can't type fast enough. This is Eric Jesperson. Can I ask one?
You can.
Sure, Eric.
Yes.
How are your efforts going to identify and attract new partners now that it's 3DHP, not just a 3DEP, like EPA and even some of your water mission and your other mission areas? How's that all working? At FEMA or Corps of Engineers, maybe?
It's coming along. We had a very positive meeting with the Corps of Engineers a couple weeks ago. I think there's a little bit different, maybe a little bit different audience within the Corps for this than for 3DEP, and also maybe some staffing changes within the Corps. We talk to EPA pretty frequently. They're maybe watching a little bit because they have longer reporting cycles. Maybe like the way to think of it, they have sort of have to have a framework that they work against for some period of time, and they are working against the NHG plus high res or a slight variant of that right now. So I think we're talking to them about getting more involved in the acquisition game. We're not quite there yet. Forest Service and RCS have been gung ho. They're in on it. Other agencies here and there.
Yeah, thanks. Keep up the good work.
Sure.
Other questions for Steve? Well, if something comes up, please pop it in the chat. We'll try and get to it before we let him go. I'm going to switch back to our slide deck right now.
Okay.
Thank you very much, Steve. Appreciate it as always. All right, I saw this morning and just had to share it. Oh, let me get way down here. It's going to be tough to hear all the laughter on Zoom. All right, not hearing it, so I'll keep moving.
I'm sure that's because everybody's muted, Linda.
Right. Okay, thank you, Greg, for the double face plant. Appreciate that. Greg, thank you. Again, so as you all know, we meet the third Thursday of each month for the forum, with occasional interruptions with the interest group meeting, which will be happening next month. So we will be doing a 3DEP interest group meeting. And again, the difference between the forum and the interest group meeting, the forum is usually where we have a presenter come and provide information about their activities or things 3DHP related that they're working on. The interest group meeting is intended more as a community discussion, dialogue, and project activities. So we'll be meeting the 15th 3DEP interest group meeting. As I mentioned, we'll be revisiting the critical factors. And I may have skipped over this slide, culvert mapping. I may have slipped over that. We're going to give you an update on what's happening with our attempts to sort of get a fix on how people are approaching culvert mapping, what kinds of attributions they're using, etc. So we'll be touching base on both of those. before I let you go, I'm going to throw one more question at you, Steve. Who's going, do you see Robert's question in the chat? Who is going to determine the status of NHD data now that it was ported into 3DHP? And how close or far is it to meeting requirements?
There we go. Yeah, so at the moment, we're really working with the idea that the NHD data doesn't meet 3DHP requirements. And sort of the most fundamental issue there is that it doesn't have Z values except for a very, very small number of HUCs that were collected in the last couple of years. We are looking at maybe other pathways, sort of what sort of variant data might be acceptable, or provisional data, on the way to getting elevation derived hydrography. But that's really Sue's terrain, and I'm not going to venture too far over there. That's sort of a work in progress.
Thank you. I see the note about GIS day conflicts. We'll take that under advisement, but we kind of have a set schedule. And again, these presentations are recorded. So if folks have to meet, hopefully they can check the recording, but I'll check with the rest of the community. Any last comments or questions for Steve and team? And Greg mentions that Phosphor G is next week, and can find, I know you'll find Doug there, so. All right, thank you, everyone.
All right.
Thank you, Steve, for presenting. Thank the rest of you for participating. As always, great for the input, and we look forward to seeing you next month, and if you're not at GIS Day. Thank you.